Hello friends, this is Priyanka. Today we are going to solve a problem on Bode plot for open loop transfer function, which is second order equation. In this video we are going to draw magnitude plot and phase plot on semi-log paper. We are also going to understand how to find out the gain margin and phase margin from the graph on semi-log paper. Let us first observe what is the given open loop transfer function with unity feedback. G of s is equal to 10 s plus 3 divided by s plus 2 s square plus 4s plus 100. So this is the second order equation, and this equation is special for this question because for this second order equation, how to find out the corner frequency as well as how to find out the phase angle phi is important to understand. Now we will move for the step by step procedure. So what is the step 1? So step 1 is this given open loop transfer function is in the pole zero form, and we have to convert this transfer function in time constant form. So what is this time constant form? That is 1 plus st or 1 divided by 1 plus st. So I will write here in the that is 1 plus st or 1 divided by 1 plus st. So this is the form that we have to achieve. Now if we observe this, for the numerator s plus 3 term is there. So we have to convert it 1 plus st. So here instead of 3 we have to take here 1. So how we can take here? If I divide here whole term by 3, then it will be 3 by 3, that is 1. So if I divide here 3, then 1 divided by 3s plus 1. So I will take here 3 as a common term. That is 10 multiplied by 3 in the bracket 1 by 3, that is 0.33s plus 3 by 3, that is 1. So here this numerator is getting completed. Now we will move to the denominator. So s we will write as it is. Now here s plus 2 term is there. So if I multiply and divide here 2 by 2, then 2 as a numerator and 2 in the denominator, that is 1 by 2s, that is 0.5s plus 2 by 2, that is plus 1. Then again for the second term also we have to take here 1. So instead of 100 we have to take here as a 1. So I will multiply and divide to this bracket as 100 by 100. So here is 100. Now 1 divided by 100 s square, that is 0.01 s square. 4 divided by 100s, that is 0.04s plus 100 by 100, that is 1. So here is the equation. So in this way this is getting converted into time constant form. Now we will simplify this. Now here 10 multiplied by 3 divided by 2 multiplied by 100. So if I simplify this, we will get 0.15 divided by s. Now numerator we have to write as it is, that is 0.33s plus 1 divided by this bracket we have to write 0.5s plus 1, and this second bracket 1 plus 0.04s plus 0.01 s square. So this is the simplified time constant form. So main important thing is that we have to convert it into this form, 1 plus st or 1 divided by 1 plus st. Now we will move for the second step. Now in the second step we have to write the sinusoidal transfer function. So how to write the sinusoidal transfer function? So instead of s we have to write j omega. So replace s with j omega. So g of j omega is equal to 0.15 in the bracket 0.33 j omega plus 1 divided by j omega 0.5 j omega plus 1, and in the second bracket 1 plus 0.04 j omega plus 0.01 s square, that is j square omega square. Now we know that what is the meaning of j. So j is equal to under root of minus 1. So j square is equal to minus 1. So here I will give minus sign, minus 0.01 omega square. So instead of j square we have to put here as a minus sign. So this is the simplified form of the equation. So this second step is also getting completed. Now we will move for the third step, that is for the corner frequency. So this corner frequency is written for each and every term from this sinusoidal transfer function. So what are the number of terms? So here 0.15 by j omega. So term means what? Which contains j omega factor. So that is the term. So this is the first term. Then 0.33 j omega plus 1, this is the second term. Then 0.5 j omega plus 1, this is the third term. And this next bracket is the fourth term. So there are total 4 number of terms in the form of j omega. So first we will write all these terms. So what is the first term? 0.15 by j omega. Then what is the second term? 0.33 j omega plus 1. Then what is the third term? Now third term is in the denominator. So I will write 1 divided by 0.5 j omega plus 1. Then fourth term is also in the denominator. So we have to write 1 divided by 1 plus 0.04 j omega minus 0.01 omega square. So this is the fourth term. So for all these 4 terms we have to write the corner frequency. Now what is the standard form? So standard form is 1 plus st or 1 divided by 1 plus st. Now instead of s here is j omega, because we have to replace s here with j omega. So we can say 1 plus j omega t or 1 plus 1 divided by 1 plus j omega t. So suppose this standard form is there, then we can write omega is equal to 1 by t. So we have to take 1 divided by t for these 2 standard forms. Now if we observe, what about the first term? So this first term is not in the form of 1 divided by 1 plus st or 1 plus st. So here no corner frequency, because standard form is not getting achieved. Now we will move for the second term. So second term is in the form of 1 plus j omega t, or we can say 1 plus st. So omega is equal to 1 by t. So I will say that omega is equal to 1 divided by 0.33. So what is this 1 divided by 0.33? That means we can say it is approximately equal to 3. Then again next form is 1 divided by 1 plus j omega t. So omega is equal to 1 by t, that is 1 divided by 0.5, which is equal to 2. Now we will move for the next term, which is the second order equation. So for the second order equation we have to refer t as the coefficient of this omega square. So I will say that omega square is equal to, now here no omega, but instead of omega we have to take second order, because here omega square is there. So omega square is equal to 1 by t. So 1 by t is equal to, t is coefficient of this omega square, that is 1 divided by 0.01, and which is equal to, we can say 100. So omega is equal to 10. So this is the corner frequency, that is omega is equal to 10. So this step is important for the second order equation. Now if we observe, there are total 4 number of terms. Out of these 4 terms, there are corner frequency is having for 3 terms. Now there is the concept of lowest corner frequency and highest corner frequency. So I will write here omega CL, that is the lowest corner frequency, is equal to, and highest corner frequency omega CH. Now how to decide that? Now if we observe in semi-log paper, each section is varied for the frequency, or we can say for the corner frequency, by the range of 10, and that each section is known as decade. Now for this each section, suppose if I write here, these are the number of sections. Now suppose here first section is getting started by the frequency 0.1 range, then for the next section it will be increased by the 10, that is 0.1 multiplied by 10, that is 1. Then the next section 1 multiplied by 10, that is 10, and the next section is 100. Now to decide lowest corner frequency and highest corner frequency, we have to observe this frequency for the terms. We have to select the minimum corner frequency and maximum corner frequency. So here 2 is minimum corner frequency and 10 is maximum corner frequency. So we have to take one range below this minimum corner frequency. Now this 2 corner frequency is in the range of 1. So in this range there is corner frequency 2 is there. So we have to take one range below that. That is, what is the one range here? Previous one range, that is before this one there is range 0.1. So we will select here lowest corner frequency at 0.1. Now how to select the highest corner frequency? So here maximum corner frequency is 10. So here for this range, here is the range for the highest corner frequency. So we have to select one range after this maximum corner frequency. So one range after this, that is 100. So here highest corner frequency we will select as a 100. So in this way, for this corner frequency, if we observe lowest corner frequency 0.1, highest corner frequency 100. Now we have to select the one particular order. So I will give here the numbering. So first, if we select the lowest corner frequency is 0.1. So out of these 4 terms, we will select, or we will follow one particular order from lowest corner frequency to the highest corner frequency. Now we will take here first term as no corner frequency. So I will give here the number 1. Then how we can choose the second term? That is, we have to select minimum corner frequency. So here this will be the second term. We will select, that is after this term we have to write this term. Then next is this third term, that is, and last one is the maximum corner frequency, that is this is the fourth term. So we have to follow this order, number 1, number 2, number 3 and number 4. Now we will move for the next step, that is step number 4. So in this step we have to make one table. So first column is for term, next column is for corner frequency, third column is for slope, and last one is the net slope. So how to fill up this table? So for that we have to take the terms in that given order that we have decided in the previous step. So first term will be 0.15 by j omega, which is having no corner frequency. Then second term is 1 divided by 0.5 j omega plus 1, corner frequency 2. Then third term 0.33 j omega plus 1 with 3 corner frequency, and last term 1 divided by 1 plus 0.04 j omega minus 0.01 omega square, which is having corner frequency 10. Now for all these terms we will decide the slope and net slope. So how to decide? Now if we observe here j omega term is in the denominator, so which is having order 1. So whenever there is s or j omega, so instead of s we have written here j omega. So I will give you here some important tips that you have to note down in your notebook. So whenever s term is in the numerator, then we have to take slope plus 20. When s term is in the denominator, we have to take slope minus 20. When s square term is in the numerator, we have to take slope plus 40. When 1 by s square term is there, we have to take slope minus 40. When s cube is there, we have to take plus 60, and 1 by s cube term is in the denominator, then we have to take minus 60 slope. Now we will decide here slope. Now here s term, that is j omega term, is in the denominator, which is having order 1. So 1 by s, that is minus 20. Then here also 1 divided by 0.5 j omega. So order 1 is there, that is we have to take 1 by s, that is minus 20. Then here 0.33 j omega plus 1. So instead of j omega we can write s, and here s is in the numerator, so we have to take slope as a plus 20. And here 1 plus 0.04 j omega minus 0.01 omega square. So here minus sign instead of j square. So we can say that here j square omega square, that is a square term is in the denominator. So when there is a square term is in the denominator, slope is minus 40. So these are the slopes. Now we have to write the individual slopes. So we will take first slope minus 20 as it is. Then net slope, that is this minus 20 plus minus 20. So we have to add these two. So minus 20 that is minus 40. Then this minus 40 plus 20. So we have to add these two. So minus 40 plus 20, that is minus 20. And this minus 20 minus 40. So we have to add these two. So minus 20 minus 40, that is minus 60. So these are the net slope. Now we will move for the next step, that is step 5. In this step we are going to calculate magnitude. For that we have to make one table. First column will be corner frequency, second will be term, next will be net slope, and last one will be magnitude. So in this first column we have to write the corner frequencies from lower corner frequency to the higher corner frequency. That is, first we will write omega CL, which is equal to 0.1, then omega C1 2, omega C2 3, omega C3 10, and omega CH 100. So these are the corner frequencies. In this order we have to write. Now next column is term. So for that we have to take the four terms. That is, first term with no corner frequency, then second term will be the lower corner frequency, that is 2, then we have to take the third term, and here is the fourth term, that is for maximum corner frequency. So in this order we have to write the terms, and then according to that we have to write the net slope also. So net slope, that we have to take from the previous table, that is for this term it is minus 20, then minus 40, minus 20, and minus 60. So remember, here we have to consider the net slope. Then last one will be magnitudes. Now here we have to calculate the magnitude. Now first, if we take omega is equal to omega CL, which is equal to 0.1. So how to calculate the magnitude? So we have to consider this first term, that is 0.15 by j omega. So for the magnitude for Bode plot, we know that we have to take 20 log of mod of that term. So here this term is having no corner frequency, so magnitude is equal to 20 log of, we have to consider this term, log of mod of 0.15 by j omega. So here 0.15 by j omega, that is, for this j omega we have to consider the lowest corner frequency. So remember, for this term here is the lowest corner frequency 0.1. So if I take here 0.1, then calculation is 3.52. So this 3.52 is magnitude. So I will mention magnitude here. Now this is the formula for the first term only. Now after that we have to use this formula, that is magnitude is equal to net slope. Now this net slope we have to take for the previous frequency. Net slope for previous frequency multiplied by log of corner frequency that we have to consider divided by previous corner frequency plus magnitude of previous frequency. Now remember, here net slope for previous corner frequency, magnitude is also for previous corner frequency, and here denominator is also that we have to consider previous corner frequency. Now we will consider the next corner frequency, that is omega is equal to omega C1, which is equal to 2. Now this table is important. Now how to define or how to consider this formula. Now here A is equal to, we have to consider previous net slope. So previous net slope is minus 20. So we will write minus 20 log of omega C1 divided by previous corner frequency, that is 2 divided by 0.1. Log of 2 divided by 0.1 plus magnitude. So magnitude also for previous corner frequency, that is plus 3.52. So when we solve this, we will get minus 22.5. Now in the same way, we will take omega is equal to omega C2, which is equal to 3. So this corner frequency is 3. So again we have to take net slope. So net slope is for previous corner frequency, that is minus 40 into log of omega C2 by previous corner frequency, that is omega C1, that is log of 3 by 2 plus magnitude. So here magnitude is minus 22.5. So we have to take minus 22.5. So answer is minus 29.5. So we have to write here minus 29.5. Now we will consider omega is equal to omega C3, and this omega C3 is equal to 10. So again we will consider previous net slope. So previous net slope is minus 20. Then log of, we have to take ratio, that is omega C3, 10 divided by 3, that is previous corner frequency, plus we have to consider magnitude. So here is minus 29.5. So we will consider minus 29.5. So answer is minus 39.95. So approximately we will take minus 40. Then again we will move for the next. So next omega is equal to omega CH, which is equal to 100. So for this 100 corner frequency, again we will apply the same formula, net slope. So net slope, previous net slope minus 60, log of 100 divided by 10, minus we have to take, or plus we have to consider magnitude. So here magnitude is minus 39.95, or simply we can take 40. So when we put all this value, answer is minus 100. So here is answer. So all these are the magnitude. Now how to plot the magnitude plot? So we have to plot these corner frequencies against this magnitude. That is, we have to consider corner frequency 0.1, magnitude 3.52, corner frequency 2, magnitude minus 22.5, corner frequency 3, it is minus 29.5, corner frequency 10, minus 39.95, and for 100 we have to use minus 100. So we have to use these two columns, and we have to take the magnitude plot and semi-log paper. We will first draw magnitude plot. For that we have to take here the frequency in radians per second on horizontal line. So this frequency is getting increased by the range of 10. So here at the start we have to select lowest corner frequency 0.1. Then we have to increase the range by 10, that is 0.1 multiplied by 10. So here is 1. Then again 1 multiplied by 10, that is 10, and next block we have to take here 10 multiplied by 10, that is 100. So 100 is the highest corner frequency. Now on vertical line we will select the magnitude, and for that we will take the scale 1 centimeter is equal to 20 dB. Now for this magnitude, if we observe the table, highest magnitude 3.52 and lowest magnitude minus 100. So we will select here the highest number, that is 10. Then as per the scale, 1 centimeter is equal to 20 dB. So after completion of 1 centimeter, we will select minus 10, minus 30, minus 50, and so on. So up to minus 90, we will plot all these numbers. Now we will select here the points. So for these points, I will choose here the red color. Now if we observe, for lowest corner frequency 0.1, magnitude is 3.52. So for this 3.52, we will select approximately 1 millimeter is equal to 2 dB. So for 3.52, after the second block, that is in between the first and second block above this 0 dB, we will choose here the number. Then we will move for the next. Then what is the next corner frequency? So for this next corner frequency 2, magnitude is minus 22.5. So 2 corner frequency, that is the second line in the range of 1, represent corner frequency 2. And what is the magnitude? That is minus 22.5. So if we observe here above this minus 30, if we move 4 block above, that is in between this 4th and 5th block, we will choose here one point that is equal to minus 22.5 dB. Then we will move for the next, that is the corner frequency 3. So this third line will represent the corner frequency 3, and here magnitude is minus 29.5. So magnitude minus 29.5 approximately equal to minus 30. Then again if we observe for the corner frequency 10, it is equal to minus 40, that is 39.95. So approximately we will take minus 40. So in between minus 30 and minus 50, there is the number, that is middle line will represent minus 40 and corner frequency 10. So with this vertical line, here is the corner frequency 10. Now for the 100 corner frequency, our magnitude is minus 100. So for this 100 corner frequency, this is the line will represent the 100 corner frequency. So after minus 90, we will say that here after this completion of 5 millimeter, there is the minus 100. So all these points are getting selected. Now we will join this point with the help of line. So I will use here the blue color to join all these points. So here is the first 2 points that we have to join. Then for the next, again we will join this. Then again we will join the next. That is, this is the third line, and then we will join the last 2 points. Now for these points, we have to show slope also. So we will show net slope, that is here. First, for first line, we will take first net slope, that is minus 20 dB per decade. Now this each block is increasing the frequency by the range of 10. So this each block is known as decade. So for the first, I will say minus 20 dB per decade. Now for the second line, we will say minus 40 dB per decade. So minus 40 dB per decade. Then again for this third line, we will show minus 20 dB per decade. Minus 20 dB per decade. And then we will move for the last line, and it is minus 60 dB per decade. So minus 60 dB per decade. So in this way, this magnitude plot is getting completed. Now we will move for the next step for the calculation of phase angle phi. So for that we will consider the sinusoidal transfer function, that is g of j omega is equal to 0.33 j omega plus 1 divided by j omega 0.5 j omega plus 1. Now here for this next bracket we have to take real number in one bracket and imaginary number in for the other side, that is 1 minus 0.01 omega square. So this is the real number, we have to take separate bracket, and outside that we have to write plus 0.04 j omega. So this is the sinusoidal transfer function. Now how to find out the phase angle phi? So for that we have to consider the different terms. Now we have to take the sequence of terms from lowest corner frequency to the highest corner frequency. Now we know that first term is 0.15 by j omega, which is having no corner frequency. So we will consider here this is the first term. Now second term, which is having lower corner frequency, that is corner frequency 2, which is equal to 1 divided by 0.5 j omega plus 1. So this is the second term, that we have to write the second phase angle for the second term. Then we have to write the phase angle for this third term, which is having corner frequency 3, that is 0.33 j omega plus 1. And last, maximum corner frequency, that is for this term. So this is number 4. So one by one we will define what is the corner frequency. That is, what is the phase angle phi for these terms. Now first term 0.15 by j omega. So here j omega term is in the denominator. So please note down this, that is whenever j omega term or s term is in the denominator, we have to take the angle minus 90. When j omega term is in the numerator, we have to take the angle plus 90 degree. When j omega square or j square omega square term is in the denominator, we have to consider the angle minus 180, and when it is in the numerator, we have to take the angle plus 180. So here j omega term is in the denominator, so we have to consider the angle minus 90. So this is the first term, so we will take here the angle minus 90 degree. Now what is the second term? So second term is 1 divided by 0.5 j omega plus 1. So here it is important to note down j omega a plus 1 divided by j omega b plus 1. How we can write the angle? So here this j omega a term is in the numerator, so we have to take plus tan inverse of a omega. And here j omega b term is in the denominator, so we have to take minus tan inverse of b omega. So here this term, that is 0.5, is nothing but b. So how we can write here? This second term is in the denominator, so we will use minus tan inverse of 0.5 omega. So I will write the next term for second term, minus tan inverse of 0.5 omega. Then third term, which is in the numerator. So for this numerator term, we know that plus tan inverse of a omega. So a is nothing but 0.33. So I will write here plus tan inverse of 0.33 omega. So these are the three terms, and angles for three term is getting completed. Now here is the fourth angle. So this fourth term is in the denominator, so again we will use here minus sign. So whenever the term is in the denominator, we have to use minus tan inverse. But how to decide the angle? So here one number is imaginary number and one number is real number. So we will draw here S plane, which is the combination of real number and imaginary number, or real axis and imaginary axis. Now this horizontal line is real axis, so on this we will write 0, 1, 2 and so on. That is the real number, positive real number. So here 1 minus 0.01 omega square. So I will consider random, that is here is the point, that is the real number 1 minus 0.01 omega square. And this j omega number, that is 0.04, is the imaginary number. So here vertical line, it refers j omega. So I will take any random point 0.04. Now what is the point of intersection? That is here, if I take this 0.04 horizontal and from this 1 minus 0.01 omega square vertical, this is the point of intersection. Now at this point we have to find out the angle. So I will join this point to the origin. Then angle made with this real axis theta, that we have to measure. So if I join here one vertical line to this point of intersection to this 1 minus 0.01 omega square. So here is the right angle triangle. So what is this vertical line? That is 0.04. Then what is this horizontal line? That is 1 minus 0.01 omega square. So in this right angle triangle, we can say that tan theta is equal to 0.04 divided by 1 minus 0.01 omega square. So theta is equal to tan inverse of 0.04 divided by 1 minus 0.01 omega square. But this term is in the denominator, so I will write minus tan inverse of 0.04 divided by 1 minus 0.01 omega square. So this is the phase angle phi for all these four terms. Now we will consider different values of omega and we will calculate the angle of gj omega. So when we put omega, that is equal to 0 in this formula, then we will get angle minus 90 degree. When we put omega 0.1, then we will get minus 91.2 degree. Then when we put omega is equal to 1, then minus 100 degree, 5, minus 114 degree, 10, minus 186 degree, 20, minus 258 degree, and 100 minus 270 degree. Now if we observe this 0.1, then here 10, then this 100. So here these are the corner frequencies. So we have to select any corner frequencies in between that. That is randomly we have to choose to draw the graph. Now we will move for the next plot, that is the phase plot. So here we have to select on horizontal line, that is the frequency from lowest corner frequency to the highest corner frequency. So if we observe here already we have shown 0.11, 10, 100. So here is same frequency that we have to repeat, and on vertical line we have to show the phase angle. So this phase angle, that is from minus 90 up to the 210. That so here we have to take scale. 1 centimeter is equal to 20 degree. So minus 90, then minus 110, minus 130, minus 150, minus 170, minus 190, and so on. So in this way, all these degrees that we have to show. Now, as per the table, if we observe for the corner frequency 0.1, angle is minus 91.2 degree. So now again we will select here the points. So if we select the points, that is for minus 91.2 degree, that is after minus 90, we have to select in between this first millimeter block, the middle point is minus 91 degree. So here is the point that is getting selected. Now next frequency we will take 1. So here is the next block will start from the frequency 1, and its magnitude is minus 100 degree. So here minus 90 degree and minus 110 degree, the middle point is minus 100 degree. Then for 5 frequency it is minus 114. So this in the range of 1, this fifth line will represent corner frequency 5. And what is the degree? That is we have to take here minus 114. That is after this 110, we have to select 2 millimeter below, because each block will represent 2 degree. So minus 114. Then for the frequency 10, that is this is the range for the frequency 10, it is minus 186 degree. So for this 186 degree, if we move below, here is the 180, and after that we have to move 3 millimeter below. So here is the point. Then after that for 20 it is 258 degree. So for 20, that means in the range of 10, the second line will represent the corner frequency 20. So for this 20, 258. So here after 210, we have to plot 230, 250, and we have to show 250, and so on. So you can plot here the next corner for the next corner frequency is the phase angle. Now we will join these angles. So these points that we have to complete. So I will select here the blue color, that is the different color to join these points. And now next for the after this minus 186, we have to show here, you can show in your graph, that is here no space available. Now this phase plot is getting completed. So in this way we have to show the phase plot. Now main important thing is that how to show gain margin and phase margin. So this is important thing. So from the phase plot, we will first draw one horizontal line from minus 180 degree. So this is the first step that we have to show the line. So I will use here the different color to show the line. So minus 180 degree, we have to show one horizontal line, and that will cut at particular point to this line, that is to this phase plot. Now it cuts the particular point. Now again from this point we have to draw one vertical line. So from this we will draw here one vertical line. So in this straight way we have to show here one vertical line. And again it will intersect here also at particular point to the magnitude plot. Now we have to draw one horizontal line from this point of intersection. So again we will consider here one line and we will take here, this is the horizontal line. Now if we observe, here is for this horizontal line, here is some scale, that is it is in between the minus 30 to minus 50. So this middle line is there. So what is the magnitude in dB? So if we observe for this horizontal line, magnitude in dB is minus 40 dB. So for this minus 40 dB, we will decide the gain margin. So gain margin is 0 minus minus 40. So remember we have to select the difference in between 0 up to this line. So how to take difference, that is 0 minus, and what is the scale? Minus 40. So we will say that gain margin is plus 40 dB. So we will write here that is gain margin plus, we have to show here as a plus 40 dB. So this is the gain margin that we will write. Now we will move for the next, that is how to show the phase margin. So before that we will also say that how to show the phase crossover frequency. So for this gain margin, if we observe, if we move here, that is what is the frequency. So for this vertical line, if I extend to the frequency, then phase crossover frequency is 9.9 radians per second. So it is slightly previous line for this 10 rad per second. So we can say that it is 9.9 radians per second. So that is our phase crossover frequency. So whenever it is mentioned that to find out the gain crossover frequency or phase crossover frequency, so for this line that will coming from this phase plot, vertical line coming from the phase plot is known as phase crossover frequency. Now we will move for the phase margin. Now from this magnitude plot, we have to draw one horizontal line from 0 dB. So again, I will select the different color, and from this 0 dB, we have to draw one line, and that will cut at particular point to this magnitude plot. Now again, we have to follow the same procedure. That is, we have to draw one vertical line passing through the point of intersection. So from this point of intersection, if I draw here one vertical line, so we have to draw this vertical line up to point that will intersect to this phase plot. So here is the point. Now again we have to draw one horizontal line. So it will cut the graph at particular point, and again we have to draw one horizontal line. So again I will take here the line. Now if we observe here, what is the angle? So it is after minus 90 degree, it is 1 millimeter below. So this angle is, or we can say phase angle is minus 92 degree. So for this minus 92 degree, we will select the phase margin. So phase margin, that is 180 plus this phase angle. So 180 plus phase angle, that is here this angle is minus 92 degree. So we will say that here phase margin, that we have to write the answer, phase margin, that is equal to 180 minus 92. 180 minus 92, and which is equal to, we have to write 88 degrees. So this is the answer, that is the phase margin. So how we can select here the gain crossover frequency? So for this gain crossover frequency, we have to choose what is the frequency for this vertical line that will move from this magnitude plot towards the phase plot. So gain crossover frequency is 0.15 rad per second. Now if we observe, this line is in between 0.1 to 0.2. So we will say that it is 0.15 radians per second. So overall, our plot will be like this. That is the gain margin and phase margin.